Okay, the audio quality of this is probably not going to be great because I'm not holding the mic anymore, but let's do this. So we're going to look at the derivatives of square, saw, and triangle. So we'll start with triangle. Here we go. Let's just draw our triangle wave right here. Okay, so it pretty much looks like this, right? Okay. Now, again, the derivative is the slope of a function at any given point. So for this whole area right here, the slope is 1. We'll say it's 1. Okay, so then we get like kind of that. And then for this whole area here, it's -1. And then this, it's +1 again. And then it's -1, and then it's +1. Okay, so it essentially kind of makes a square wave kind of thing, but not exactly. I mean, a mathematical square wave is what it makes, but not a real square wave. And I'll explain that later. But then you take the derivative of that. The slope is always 0 here, so yeah, there you go. So that's 2 derivatives, and there you go, 2 derivatives. And we are at a straight constant value of 0. All right. Now, next we'll do the square wave, so we can explain that little like mathematical versus real. So a square wave looks like this, okay? And it has these like connections. Like it goes from kind of 1 to 0, or 1 to -1 to 1 to -1, but it has these like lines in the middle. And that's important because in the real world, the diaphragm does have to move from here to here. Okay, if you don't understand what I'm saying there, watch my video about speakers. But the diaphragm has to move. Like, it doesn't instantly move to here. That's just not possible. And if it did instantly move there, you actually wouldn't hear any sound ever, because the speaker would essentially never be moving. Anyway, so what we actually have here when we derive this is a period of 0. Okay, so we got 0 slope for a while. But then here, we have an extremely negative value. Okay, so just like a really negative value. So we'll like do that here, but it lasts for an extremely short amount of time, and then it's back to 0 for a while, and then some extremely high positive value. Okay, and then 0, and then negative, and then if we derive that, then we're just gonna get 0 the whole time. Again, 1, 2 derivatives, and we're at 0 again. Okay, because slope 0, 0, 0 everywhere. And since this is now a mathematical thing, we're not in the real world once we find the first derivative, we're just in a mathematical world, there doesn't have to be a connection there. So there you go. And finally, we will do saw wave. So saw wave kind of is a similar thing to the square wave. It has this thing that you think is like an infinitely fast thing, but it's not in the real world. There is an amount of time that it takes for the speaker to go there. So yeah, so this depends on which polarity you have the saw wave at, whether it's flipped or not. But here we have a -1. If it was the other one, you'd have a +1. So you have -1 for a while, and then a super high value for a very short amount of time, and then -1 again, then a super high value, and then -1 again, then a super high value. Okay, so you get the point. And then, again, now we're in the mathematical world, so we don't actually need that connecting line. One more derivative, and it's 0. 1, 2, there you go.